This is TMUA 2021, Paper 2, Question 4. We're told to find a counterexample to the statement if A divides BC, which means A is a factor of BC, then A divides B, or A divides C. In this question I note A line B, which means A divides B, which is the same thing as saying A is a factor of B. And we want to know which of these is a counterexample. A, B, C is either 5, 10 and 20, or 8, 4 and 4, or 6, 7 and 12. So what does it mean to be a counterexample in this case? Well, in this case, to be a counterexample, it must satisfy the first statement, that A divides BC, but then we must have that A is both not a factor of B and not a factor of C. So let's analyse statement 1 with the first counterexample. So BC is 10 times 20, which is 200. So we have A is 5. So 5 divides 200. That's good. So we satisfy the first part. Now we need to show, for it to be a counterexample, we need to have 5 not dividing 10 and 5 not dividing 20. But 5 does divide 10, because 5 times 2 is 10. So this is not a valid counterexample, as A is a factor of B. What about the second option? We have BC is 4 times 4, which is 16. And then A is 8, so 8 divides 16, so 8 is a factor of 16. And then, is 8 a factor of 4? No, because 8 is bigger than 4. And because B and C are the same thing, it's just this statement. So it is a counterexample, as 8 divides 4 times 4, but 8 does not divide 4, and 8 does not divide 4. What other statement, the other one? When we have B and C is 7 and 12, BC is equal to 72, and A is 6. So 6 does divide 72, so we're good. And does 6 divide 7? No. But 6 does divide 12. So A is a factor of C. So this is still not a valid counterexample. So the only counterexample that works is 2. So the answer is C. On a side note, you should know that if A is prime, then this statement is actually true.